also quickly give you one of the GitHub repos, I think, that are really important as well. Let me see where I can get them. Okay, this. So basically send you to the GitHub as well, so you can follow along for the code. Where is this? Okay, so first of all, welcome everyone here in the Discord and also everyone who's live, via Binance Live or via YouTube. Welcome. I will get you an example here that you will need for this if you like to code along afterwards. Let's just get that one for you. And let's go here. Exactly. So oh yes, good point. Yeah, sure, of course. Let's give them some time. Let's just let them introduce themselves, and then we can, of course, go with the workshop. That's perfect. Yeah. Go ahead, 0x Karthik. If you'd like to introduce yourself, please. Yeah. Okay, you're having some issue. Okay. Yeah, sure. No problem. Just tell me when you like. We're at the end of the presentation or at the end of the workshop, then you can easily, just write it in the chat, and then let's just do it this way. That's perfect. Okay, I've also posted an example here that you might need. But let's put that aside first, and let me just do some explanation of actually what you can do and what you can't do with Secret VRF. And you're gonna be surprised, you can do a whole lot of things with Secret VRF now that we basically did the legwork to make it, available to the whole EVM and Cosmos ecosystem in a way that I'd say is easy to use, and that's why I basically named it like this. So the idea behind it is we have for a workshop is just in general, how do we do cross-chain randomness? Or in other words, how can we do like VRF, basically, like just in general, like RNG for EVMs in just 10 lines. That's the idea behind it. So now the question that we have is, if we're gonna go cross-chain, how are we gonna do this? For EVM and for Cosmos, the approaches are completely different. Just because it mainly depends on how the architecture is made and how you can bridge messages back and forth. For EVM, I have this little snake here that I will show you afterwards what that is. And for Cosmos, we have so-called IBC hooks. So for people that already know Cosmos, IBC transfers are essentially something that you can use to transfer assets between Cosmos-based chains, Cosmos SDK-based chains that support IBC, for example, between Osmosis, between Secret, between Cosmos Hub, or Neutron, or whatever other chain, or Juno, for example, or any other Cosmos-based chain that has IBC hooks enabled. And I will get into afterwards how this exactly will work. And now, what I wanted to go on first was, how can we actually get VRF into EVM? Because that was one of the price questions that we always want to answer. And, competitor market for VRF isn't that big. And I think we have something that is very easy to use, and we wanted to get your, what devs to get their hands on. And that's exactly what I'm going to show you today. How can you get a grip of this as fast as you can? How are you going to do this? So approach is pretty simple. What's that snake? Well, the product that we have is so-called Snake Path. So we're going to call it Snake Path, or that was basically a project that was done quite some time ago by a very valued community member in Secret, and like a team that they did it, created this. And what Snake Path allows you is to essentially bridge messages from EVM into Secret and also bridge it back. And that way you can easily get, for example, VRF into EVM without without doing a lot of legwork basically for devs. Because, what we think is devs need something that's easy to use. You know, don't need to think about a lot of extra stuff. You just want to have an easy to use VRF. That's it. So now the question is, how does SnakePath actually work? Because I think someone might be concerned how this specifically works. It's actually a whole bunch of things. So SnakePath is like a collection of contract plus relayers. And now the idea is how is it actually composed. I will just give you a rough overview. It's actually quite a lot, but just to give you a rough overview, what's actually happening, just roughly. We don't need to go into the specific details. That's way beyond the scope of this presentation. But what I want to say is the idea behind it is that you have two contracts mainly, which is one is the master public gateway, which is the contract that lives on EVM, on your EVM chain. Well, it could be Ethereum, could be any L2, could be like any sidechain like Polygon, whatever. Doesn't matter, as long as it's EVM compatible and basically enables you to have to admit logs. That's all. That's everything that we need. Then we have a relayer network. That relay network is trustless, so we don't need to actually trust them. We don't care about if the relay actually is malicious or not. The only thing that we're really going to have to trust is actually the master private gateway, which is the one in yellow. And that's a smart contract that lives and is executed in secret network. And this is basically where everything is basically revolving around. And here in the end, you basically have your code, for example, to do some private computations. Here basically to submit stuff, and here on the other end for the user in a private contract to, actually do some private computations. The thing in general is SnakePath doesn't stop at just providing VRF, really. You could use it for doing a whole bunch of privacy-preserving computations that you might need on Ethereum. It's not limited to just being, well, that's something for VRF. But I think, and that's something that we wanted to, emphasize in Secret is the fact that you want to, start small in that case and, bring something that's easy to use for devs. And VRF is the perfect use case for this. So SnakePath has a whole bunch of other super interesting use cases that you can use. You can do, for example, could do private voting. You could do just encrypted key value storages. You can store like blobs on there, like whatever you like. But I think for a first use case, VRF is a very nice one, because Secret, what happened with VRF is that it leverages very special function inside of the Secret enclave. So inside of Secret here, basically Secret runs on trusted execution environments, specifically on Intel SGX. And in that case, we can leverage this fact that this enclave can actually generate us truly random numbers. And when we have an easy way to have random numbers, we can easily disperse them using SnakePath into EVM. That's the idea behind it. So now the whole question is, how important or what in this chain do we actually need to trust, and what do we not need to trust? I think the whole idea of SnakePath for most EVM users to see if this makes sense or not for them to use is the fact that, just to explain the core idea behind it, and I think that might make sense. Idea behind it is you will have a master gateway contract, so here, that is on Secret network. And what this does is this contract will actually sign bridging messages. So you have a private key that's stored inside of Secret, inside of Secret network, as Secret is a that enables you to do privacy-preserving computations, confidential computations, however you like to do it. The idea is you can store a private key inside of the smart contract, inside of this gateway. And this private gateway can then sign messages that you can verify in EVM or in any other way that you like, as long as it can check 256K1 signatures, which is super common in basically every chain that you have right now, especially in EVM, of course, in EVM space. So this is the key thing. You have a private key that's stored inside of the contract that can sign messages. And essentially, the whole idea behind SnakePath is that you build everything else around this fact, that this gateway is protected, and that this gateway actually holds a private key to sign messages that no one else can have access to, not even devs or like the host or whatever, like the chain doesn't have access to this private key. No one can see this private key. It's stored exclusively inside of this master private gateway contract. And essentially, The idea behind it is everything around this gateway is built to just ensure that data wasn't manipulated along any path. So we have a lot of signature verifications. You do a lot of hashing to ensure that stuff wasn't manipulated. Then you check signatures again. And so on. The important thing is at least do a ton of checks to ensure that stuff wasn't manipulated in any part of this chain. Basically, where you do some, where you do relaying or verification. So essentially, what you have is, in general, you have this trusted master private gateway that signs messages, and for DF specifically, you also need to trust the gateway contract that the message came from. This is just really to ensure that you have, when you receive a call from this gateway, this will be used to call your messages, so you call back. That's why you need to trust DF, I guess.
How would you explain like signing and signatures for people who might not have worked with cryptography before?
Very good point. Essentially, it's very good point. So the idea behind it is, if you're not really familiar with how stuff is signed, it's essentially the master private gateway, as I said, holds a private key. So that's in essence your signature. So if you take it into your real life application, it would be you only have your own hand, and you can only sign your own signatures, right, with your hand. In the same way, the private master gateway contract has also its own signature, and only this contract can sign messages. So what you have is, you have like a message that says, well, I have these random numbers for you, and I have this description that you like, and job ID and whatever, so request ID. So requested something, and here are the random numbers. Plus, I give you like a signature. So basically, this gateway contract signed it, just like a person would send you something to attest that it's from them. And what the master public gateway can do, and everyone else can do, is they can always check if this signature, that this gateway here created, is actually made by it, not by someone else. I hope this explains it a little bit better. So of course, there's a lot of elliptic curve cryptography in this. So it's just like, so SecP 256K1 is an algorithm for providing signatures. So of course, we don't go to specifics, and that's exactly what we wanted to do. We didn't want the EVM devs be bothered with this kind of work to do. Oh, well, do I have to verify signatures? Do I have to we don't want you to do this. We only want you to be, the steps that you do is essentially just you call the contract here, you call the gateway here, you request a random number, and it will come back. And everything else will be taken care of. You don't need to do any signature verification. You don't need to do anything. You don't need to check stuff. We basically do everything for you. You just have to say, well, does the random number come out of this gateway or not? That's exactly what I'm going to show in the demo. So wait until we get there. But essentially, a signature, the basically key thing is this thing signs stuff, so it gives you this attestation signature that it was actually created by the gateway. And in real life, it would just be like you basically signing stuff with your own hands, putting a signature on a piece of paper. That's basically the same thing, just in digital. If you look at the analog, of course, it's not really exactly the same thing. Obviously, I'm not gonna go into that, of course. But if you're not familiar with signatures, this is how you would probably imagine. Can I answer the question?
Very much so. Thank you so much.
Of course. Perfect. So now that we roughly got a structure of how SnakePath works and how the core idea behind it is, of course, there's a lot of more steps involved in how to do it. In this presentation, it's actually super interesting, but it will take a lot of time, and it's not really interesting for devs. But that said, for us, the goal was to make it, make secret simple for EVM. So we wanted to, everything that's basically complicated, we abstracted this away, and you basically just have a drop in, just a drop in the contract, just a code drop in the contract. So you just drop in some code into a contract that you have existing, probably maybe you are using secret graph in some other way, using, for example, Chainlink VRF. I think that's the better thing. Using only some other VRF like Chainlink. In that case, maybe it's because the drop-in is pretty similar to how Chainlink operates, just better and easier. And you're gonna see why I'm saying this. So important thing is everything that's complicated for you is abstracted away. You just drop the stuff into the contract, done. And it works as intended. So now the question is, I'm gonna give you 10 lines because it's kind of a flex, I'd say. So the idea behind it is if it's really just 10 lines, then it's kind of 10 lines. So first, you just need to define the interface. Basically, that's just for you, for your contract to call. So you request some randomness. If some of you might remember, maybe familiar with Chainlink VRF, who knows? Maybe not. Maybe in some easier way. Basically, you define it in small space. Then you just save your VRF address. So basically, what you have to do is you look back on the contract here. You basically need to save the address that lives in VM space. You need to save this address on the contract. So you, as a dev, always call this public gateway. Say, well, I want some VRF numbers, some VRF or some RG, whatever, and you will call this contract. This is essentially what you're going to save. You just set the gateway address, and we have a specific table for this on the box, so you can always look up which address is the correct one for your chain. We've supported in testnet and on mainnet. You can test this. I wouldn't say exactly everywhere, but on the most, let's say, most popular, chains to deploy and to test. I think that's the most important thing. I'm going to show this also in the demo. Then, this is the beauty of it. So you might think, well, you don't even have to do some fancy inheritance or so. No, you just need to basically have your basically just put these basic stuff in place for the request randomness and the gateway address, so you know what contract to call. Then the real beauty lies in how we're going to call the contracts, which is pretty easy on how we request our random numbers. I just called this here request randomness test, which contains a number of words. How many random numbers do you want? We support up to 2,000. Could even be more in the future, but right now we just want to make, let's say, something that we know that at least would definitely work. And I think 2,000 words is more than enough for most apps. So I don't expect you to use it. It's possible though. We can try it out. And important thing is a callback gas limit. And to be honest, we just kind of thought how complicated do we want it to be. And the answer is we don't want it to be really complicated. So what we wanted to have is something that is just simple as an idea, which is if you basically the callback gas limit is just limits that you define for the callback message. So that includes everything. You don't have any that you to calculate. You essentially have a message that comes back. This message that comes back into EVM has this callback gas limit. I will show you what it means. I can exactly show this in the demo just to make sure that you understand this one, because that's really important to really, have this correct. Good thing is, if you actually don't, you're not going to run into any problems. But I'm gonna make it. Now we're just going to define our interface, our instance of VRF contract using the address, and we will request this. And you're gonna also, of course, pay some value into it. So you have to pay for the callback gas. Essentially, you prepay your callback gas using your native gas token. There's no extra ERC20 token or anything. You just pay native gas. Total gas cost for this call is low. Also doesn't make it complicated. And you say how many number of things you want. And then, just as a good measure, in our case, just emit the event, just for a second. In your case, you would probably do some preparation at the top here, maybe request randomness, and then maybe save it into your storage, whatever you have, right? If you have some mapping, you could store the request ID, and then afterwards you could retrieve it. And then from that point on, VRF and Snake will take care of everything. and you will just wait usually 1 or 2 blocks, mostly 1 block, if you have 6-second block time or like a bit more on, for example, Sepolia, and it will actually fulfill the random words, and you will just call this function. You might be able to recognize this from some other competitors. And essentially, it's just you get the request ID back that you initially submitted, and that the contract essentially gave you back, which is this one. So you just get a request ID back. You can use this to track your event that you have, and afterwards you get a 256 array number of random words that you requested. So if you 10 random words, you will of course get a UN256 array with 10 entries for your random words, and then you can do whatever you like. The important thing is, and that was important, of course, protect against any any wrong submissions in your cases. Check if this stuff was actually sent by our VF gateway or not. That's of course important. The VF gateway, secret, so the gateway basically is takes care of it, that the stuff was actually correctly submitted in secret and whatnot. That's all verification to check, oh, did this message really come from the gateway? If not, of course, then you need to abort. But verify that stuff came from the gateway, you can trust the gateway that actual stuff came from it. Then, for example, you can do custom stuff. For example, if you have a raffle or an NFT randomization, whatever you like, doesn't matter. Absolutely your choice. You have absolute flexibility in this, of course. There's no limit. In our case, we just said, well, we're just gonna emit the event and just, emit the event and just emit the random words. That's it. So nothing too fancy, just for the demo. We are very excited to do this. This is gonna be super interesting, and let's see. We're really so what's your choice gonna be? So let's jump into the demo. It's actually easier than explaining the code, by the way. Let's just switch screens with this. Yeah, that's the one. And let's just. Is it good to see now? I guess would be good. So what I did is we have an example contract here, exactly what Sean had already posted, and we have this example in Solidity. I'm just going to post it here again for you. So please go through this and copy this into Remix if you'd like to follow along with me. Give me 1 minute to do that. Just create a new file, whatever, and maybe use a selected provider, use MetaMask, and I would recommend you use Sepolia right now. I think that's the best way to test it out. Exactly. So the idea behind it is you first deploy a contract. So first of all, what we're going to do is we're going to deploy this contract. Gateway, and then we're going to do some testing. Basically, we're going to request some random words, and then we're going to see how it worked out. That's all we need to do. There's not a whole lot of things to do. Basically, you just need to drop in these pieces of contract, which we have a tutorial as well. So Sean also linked to it. Good question, Valentin. I will answer this afterwards, okay? I think that makes sense to answer afterwards. But very good question indeed. Okay, so if you're on the same page as me, it's pretty easy to pull off. We're just going to deploy this contract with enough gas limit. I would pick 2 million for this, or maybe 3 million. Let's take 3 million, okay? So the idea behind it is so if you look at the stuff, you need to be aware of 2 things. First, of course, you need to compile it. Then for deployment, that's the interesting part. You need to be take an account that actually has some testnet Sepolia in it. If you haven't, I would recommend you take the POV faucet for Sepolia. That's quite a good thing here. For example, you can use that afterwards if you like. Pretty useful tool, I'd say. We can also put this in here because that's the easiest way to actually get testnet supported without logging in too much. And I think at that point we can actually deploy. So what we're going to do is we just, in my case, I just use MetaMask and make sure to actually deploy the correct contract. So if you have this interface here, Remix will actually suggest that you deploy HackSecret VRF, which is wrong. If you try to do this, you will get this message. You will get this alert and it doesn't work. You need to be here, you have to actually submit randomness receiver. Oh wow, that's actually writing it right now. Perfect, but that's imperfect, so it's actually also good. Anyways, in our case, we got this sample contract as I just shown you basically here. Nothing fancy. I just had an extra function in here, just extra testing or whatever. And here's the callback. So what we're going to do now is we're first going to deploy this contract using MetaMask. I'm going to deploy it as such. So created here the message. So it's pending. Let's see. Just sign the message in MetaMask. You can also look at Sepolia. You can also look here on the creation. So we just created this contract, so we can view it on Etherscan. Fresh out printer press, I'd say. So we created the contract. Now that we created our contract, we need to only supply it with our VRF gateway. So what you could do is you can potentially in your contract you could do it as I do, basically just save it as a public address, and just store it in the contract. That's it. That's probably the best way to do it. You can maybe even hard code it if you like. Although generally I wouldn't recommend this one. I would just store it basically. That's probably the best way to do it. So we just deployed this contract. So we have this contract here as well. It's not verified, but in Remix, so we know anyways what it is. Now, what we need to do is we need to set the gateway address. So if you look at the deployed contracts down here, if you can see that one, we can look up the owner, which was just our address. And we still haven't defined our gateway address. So what we need you to do is you go into the docs and specifically this page, which gives you it's in the main stage now. You can look in the chat and you can essentially look at the gateway contract. So we have a bunch of network supported. It's Ethereum mainnet, BSC, Polygon on mainnet, Optimism, Arbitrum, Avalanche, Base, and Linea. So a lot of chains that you can use. If you, for example, like to have other chains supported, please do not hesitate to actually ask us. We're actually very happy to deploy the contracts on more chains. We're just looking for the most popular ones, and if you have some suggestion or like more, please come to us. We're really happy to deploy it. It's not really hard to do it for us. We just need to deploy the contract for you on EVM, and that's everything that we basically need. Then, so you can take a look at it here. I've also posted it in the chat, so make sure to check it out afterwards as well. For testnet, we have a lot of possibilities. We have Ethereum Sepolia, Polygon Mumbai, Optimism Sepolia, Arbitrum Sepolia, Base Sepolia, and also Bera chain. So I think that's good for a start. We're also going to support more testnets soon. For example, Etherlink is also one of the lists that we're going to support pretty soon. So make sure to check this out afterwards as well. But there's a lot of testnets you can pick from. I would personally just use Ethereum Sepolia just in that case. And in my case, that's the best thing, I guess. Important thing is, here is a list of all the gateway contracts, gateway addresses, and the proxy admins. The proxy admin is not important for us. That's just for you to see who is the proxy admin who can upgrade the contract. Because we made the gateway itself upgradable in case we want to make improvements, which I have actually something on the way already. Doing some more improvements for error handling and then how you would see the errors. I think that's very important. So we already have some updates for the gateway in pipeline, so we can always upgrade it. But of course, you need to see what the proxy admin contract is. But what's most important in our case is at least here's the gateway address, and that's actually the address that we're going to call. And what we can do is we can use the function here, set gateway address. So that's one. We can add this here. Okay. We can use this in Remix to add this one. And we can confirm it. Let's see, just confirm the transaction. We're just going to set the VRF gateway. So we just submitted this one as well. So as you can see, It's basically just deploying the contract as you would do it anyways, and then as an intermediate step, you can call this function separately. Maybe you can even call it in the constructor. Just completely up to you what you like more. There's absolutely no real limit on how you would do it potentially. Just pick whatever you like, do it in an extra function, do it in a constructor, whatever you like more. In our case, it is made in an extra function, so we just set the gateway address, as you can see here in etherscan. And we can, can take a look at it, what we set. And as you can see, that's exactly the gateway address that we wanted to have. So now, that's it. We can now request a randomness. That's it. There's nothing else to be done for the setup. You don't need to do anything super fancy or anything else. Now, the only thing that's really left is, one thing that's important is, of course, now we're ready to call the contract, really. We can request a randomness pretty easily. And what you can do is you can use this request randomness test function. In your case, do whatever you like. It's just a sample function if you like to get to know it more, right? And you have a callback gas limit. So now the real question is, and I think that's one of the hardest things I want to give you along the way, is actually, of course, this stuff cannot run for free, obviously, because if you do a callback, the relay actually has to pay, and the gateway actually has to pay for the gas to do the callback, obviously. And for that, we need to have some small of, like, you need to prepay a small fee, prepay it before you do the computation, to just cover these gas costs. This callback gas limit is surprisingly simple. It is just basically, you would just have a transaction that comes back. So in our case, I can just show you in our example here. For example, I did some examples beforehand, some checks. And this is the gateway contract. And you will, essentially what you have is, if you did a contract execution, you have this post-execution. So basically the stuff that comes back. And this post-execution function has a gas limit. In that case, it's 90,000. This 90,000 is this callback gas limit. So basically, for doing the callback, the stuff that goes back, this whole computation you need to make sure that you define enough gas for the callback. That includes the verification, plus the signature verification, plus of course, the bigger payload, or the result, let's say, for the bigger call data size, plus the stuff that you want to compute. If you do not have enough, the transaction will fail. Simply enough, it will fail. Good thing is, at least you can recover from this. So if you, for example, maybe didn't pay enough gas fees, you can still recover it, because the idea is that these relays are trustless. So you don't need to trust the relays. You can actually push the stuff by hand if you even like. The contract is the only thing you need to trust, as I said before. So if this callback actually fails because it doesn't have enough gas, you can actually push it again. If it's already executed, you can push it again. So of course, you can only execute it once, not multiple times. But if it failed because if it reverted because of gas being too low, you can still push it by hand. If that's the case, for example, in something that happens in your case, please just come to us, ask us in the chat. We're basically building up the docs for some error recovery. But in essence, you can always push these transactions by hand. So in that case, if there's some problems, please just come to us. We're happy to help. And in the future, I'm also going to provide you a tool that will allow you to, query these messages. And if something was stuck, you can always, resubmit it with high gas limits to make sure that you actually can push the transaction through. But that's basically your callback gas limit. Make sure you pay enough for this. So for example, in my case, I want to have 30 random numbers. We can actually do up to 2,000, but it's just going to burn so much more gas. But let's just do 30 of them, and let's just take 300,000 as a callback gas limit. So that's, again, that is the maximum that the relay is going to pay for post-execution, so for your stuff that comes back. So let's do that. And everything else is handled by the contract. So now the thing is, after you defined your callback gas limit, you need to make sure about another thing, obviously, because the thing is, as I said, you need to prepay your gas if you want to come back. And the VRF contract here will actually check if you paid enough gas. If you don't pay enough, it will fail and you will get an error. I will show this to you as well. So for example, we have this in the tutorial here as well on how to do this. This is exactly here. Actually have the code provided to you as well. Just check it out here. So that's basically one of the few caveats that you need to keep in mind. In case you have problems estimating this limit, please just contact us. We're really happy to help you about this. This is important. So please come to us. Don't be afraid if you think maybe it's a dumb question. No, it's not. Please come to us for this. And now the thing is, since we have this, so what the contract will do, basically the gateway will do is it will estimate a request price. So what it will do is it will see how much did you demand in gas limit, what's the callback gas limit, and it will just estimate the fees by the block base fee. So it's, as of right now, this is just basically cost covering. You're not really overpaying anything. You're just basically paying the bare gas costs to come back, which is already like minimal because we actually made sure that the callback is pretty gas efficient. We actually did a ton of optimizations for this to make sure that it is. So for example, a callback with just, 20 random words is just 72K gas. And that includes the whole verification, the call data, and everything. So it's extremely gas efficient. And that way you can, of course, save a lot of money on gas. And that increases profit margins again and again. So, and also doesn't waste resources, which is already sparse as well anyways. So now, this doesn't use a lot of gas. Actually, we can provide you with more data afterwards, but you can also try it for yourself, which I'm quite happy actually. Just try it out, use it, abuse it actually, do whatever you like. This is good. If you break something, good. Please report it to us. We're really happy to help you out and also fix stuff if something broke. So now, that's the question. So since we actually need to estimate this price, I can show you what happens if you do it incorrectly. Two things. First, we're going to do it incorrectly, okay? We're going to call this randomness contract, and we're going to request some random numbers without paying anything. We're greedy. So let's try this one out, and let's see if it works. I will tell you it won't, but let's just try it out. What will happen? If you're not paying any gas, this is what will happen. Let's just wait. Transaction will fail, and it will just fail. It will tell you that just failed. That's it. That's about it. So as you can see, it correctly failed because you just didn't pay enough gas. As you can see, contract execution failed. That's expected, of course. Now, if you correctly estimated the gas, so what we have is we have a demo here, a VOF demo, and I'm going to show this to you afterwards. And this demo, I actually have the code inside for you to estimate the gas correctly, or you can use the docs to estimate the price by yourself. And of course, add some overhead to make sure it actually passes. But in general, you need to watch out for this gas price estimation. That's basically the only thing that I would say is mainly what you need to think about when doing this. That's it. You just need to make sure that you actually pay enough in callback gas to do the callback. That's it. I think that's the hardest part in the whole equation here. So yeah, let's try it out. Now we're going to pay some gas, and obviously using estimation that we had, it's callback gas limit. So we had 300,000 in gas, callback gas, plus base fee. What is it? 70 gig away. What is it? So let's do some estimation for it. We can easily do that. So let's do 300,000. I mean, you can always do this in code, right? Just implement it in JavaScript. Also have the code available for you for this as well in demo. We can just estimate it, which is 21 million gig away. And we can use that and just add a margin, pick whatever you like. I like to use usually, let's just do 31,000, just add a bit. And let's try it again. So what you now do is you define your callback gas limit, you define the number of words, and you pay some of this you basically paying your callback. Now let's transact. And let's do it. I think that's actually the hardest part of estimating this fee, to be honest. Like for me personally, that was always the hardest part, correctly estimating this fee. If you do it correctly, then you won't have any problems. But of course, that's an UI thing, so you need to implement it into UI. Good thing is, of course, that we have a lot of functions, Ethos.js and other libraries. As you can see, it's successful. So if you prepay the gas correctly, that's totally fine. and actually requested the random numbers here, and actually just used 92K to do the request. So quite cheap anyways, if you compare it to any competitor that we have. So now we did request the random numbers, and now what we can do is it actually sends the 0.031 ETH to our gateway contract. So the gateway contract actually holds some balance now. And what already happened, as you can see, is it was actually faster than I was even talking. So this callback post execution here is the result already. So we basically requested at block 003, and it's already came back at 005. So within 2 blocks. So it's basically it just registers the transaction, immediately executes it, sends it back. There's pretty much no delay in between. As you can see, it's successfully executed, and we can show you the logs of it. So what it did is now it basically called the VRF in the background. The relay did the work, relayed the messages, executed the contract, and the contract itself, the secret gateway contract, signed the message, sent it back. And that's what we already have in post execution. So as you can see, it happens blazingly fast, and you don't need to do anything in extra work or so. So as you can see, it took here 36, and the block itself came back in 12. So it's basically as fast as you possibly can, right? Within 1 or 2 blocks. It mainly varies. Like, it's just basically random at that point if you have 1 or 2 blocks, but it's almost within that range all the time, I'd say. So now we have this post execution. If you look at the logs, oh well, we have our request ID and our random words. As you can see, we have exactly 30 random words as we wanted them to be. And what the post execution did, it just executed this fulfill random words function. We did a check here that the secret gateway can only fulfill this, and that's it. And then we can do our emits. In our case, we emitted these words just for good measure. This is an example that you can do. That's it. Voila. You got your random numbers. Exactly. So I think that's the whole demo. That's it. Like, there's code is extremely small, extremely lightweight. You don't need to do a lot of thinking. The only thing I'd say is you need to really watch out maybe for the request randomness here, for paying enough callback gas limit. If you look at the callback gas limit, I can also show this one to you. In that case, we said we wanted to have 300,000 callback gas. This is exactly what the relayer did for sending it back. And as you can see, you get 30 random numbers for just 82,000 gas. So it's extremely gas efficient as well. Yeah, I think that wraps up this demo. Questions to this? Please hammer me with questions if you have something. If not, please, if you don't have it right now, please just ask in the HackSecret main chat. Ask us in Telegram, whatever you like. Always happy to help you. 0x Karthik wanted to say something, or do you want to go on to Mike right now? We can also do that one right now and just have some minutes to. Yeah, happy to introduce. If you'd like to introduce yourself, please. Oh, and Pope. Yeah, sure. Pope as well. And okay, let's just give 0x Karthik the first thing to introduce. Let's just introduce yourself, and then maybe Pope can ask afterwards. I think that's a good idea. Let's do it like this. Let's see. Can I give you mic permissions? I think you can just unmute yourself. I think it should actually work, or should we? Can we enable it, Sean? Let's see. Can we enable it for him?
What's that?
Can we enable it for 0x Karthik for he wanted to have mic permissions?
Okay, give me 1 sec. Let me see.
Can we enable it, because I wasn't quite sure if it works for him. But aside from this, like, if there are any other questions, just if you have some questions afterwards or not, please do so. Good thing is I also have a demo for you. So for example, if you like to try it out in just with a simpler UI and you want to see how we did it in the front end, Also with the gas estimation, I will also recommend this one to you. I will also put this in the docs later on. If you think the docs are not sufficient enough, please just ask us as well. We're really happy to, always enhance them. This is a breathing and living thing for us. The docs at least are, and we're really, really happy if you have some suggestions, critique, whatever you like. It's just we just want to make them better and more comprehensive. And if you like to check it out, the VRF demo yourself, you can just use the VRF demo, which is just the same thing basically that I did by hand in Remix, just with a UI. In that case, I can also show this one to you. We can easily do a dice roll, which is the same. It just estimates the gas costs for us, so there's no need to do it. So for example, we did the gas price estimation is done by the UI. That's what I would always recommend, of course, if you have some user. So as you can see, we did the call here. This one here, and then what it will do is it got the request ID, and it will just wait for the callback, and then it will show you the dice roll. So we can use these random numbers to simulate dice rolls. Essentially, that was like a simple demo that I wanted to show everyone. You can always also show this to your colleagues if you like. This is a super simple demo. Just get some Sepolia ETH. That's it. As you can see, boom, you got your random numbers here, your dice rolls, and you have your contract call as well. Super simple demo, easy to show, and there's implementation work is pretty minimal, I'd say. So as you can see in Remix, it's pretty simple to do, and I think that's why we wanted to get it in the hands of everyone as much as we can. Exactly. So okay, if you've got access, then please go ahead. Let's go if you can.
So hi guys, I'm audible, right? Yeah. So I'm Karthik, and I got my teammate here, Tisa Prince. So we have been following SecretNet for a while now. So I started my journey as a EVM developer, and slowly I just got myself into Cosmos. Like I loved the entire consider Cosmos was. And recently, like a few months back, I got to know about Secret Network from Poplack. We connected on Twitter, and it was a great start. I explored about how this is about all these things, and really got into the interest. And right now, we are here participating in the hackathon. So we are building something that we think is essential for our place. So there are a lot of issues regarding not fake news is revolving, and journalists are not able to publish actual news due to a lot of issues such as identity reveal and all those related threats related to that. So I think Secret Network is a good platform where we can build a platform for this kind of journalists to actually publish their own resource works, at the same time keeping their identity unrevealed and basically get rewards and returns. So that is something what we are planning to build over this.
Sounds super interesting. I mean, if you have questions, I mean, how many people are you in your team for the hackathon specifically? 4 or 5, I guess. Like pretty packed, I guess.
Currently, we are 2, me and Tisa Prince. He's also present in the talk.
Okay.
Okay. Hey guys, actually, I have joined on the same device as Karthik. So I'm actually a full stack web developer, and I think Karthik very well introduced our idea for the hackathon. So yeah, we are both working for the same project.
Okay. Awesome. So just in general, if you have just questions, I mean, feel free to ask him either here. I think I still have some one or two slides to show you, because it's more for the Cosmos side. So let's just do this afterwards. I think if you have more questions, you just can DM me on Discord. Just ask in the chat. Everyone is welcome here. Especially someone who's like, this is something that we also have. Is like quite a lot of people who are like always lurking into Secret, but they're not really doing the dive into it. And we're really happy if someone, takes the dive, takes the leap of faith, I'd say, and dives in and tries it out. Really happy. Thanks a lot for joining.
Thank you.
Awesome. Let's just go back to the presentation that I have. I still have something else, because the thing is now that we got EVM stuff done, Sarpritz is writing something. Let's wait for him again. It's a switch in the meantime anyways, and if there's a question, go ahead. I'm diving, yeah, please do so. Really happy about it. Please just ask us, even if you think the question is dumb. There is no dumb question. I'm gonna say this. I'm gonna have to say this all the time. There's no dumb question. Please ask everything that you might think that's not obvious to you. Secret special and it is a nice platform, by the way. So there's a lot of like smaller quirks because you have privacy, but once you understand these, like it's really worth it. So yeah, if you have a question, please just bombard us. I'm really happy to answer every question that you have, even if it's not specifically dev related. It doesn't matter. Really happy to help you about this. Okay, Ohms and Sub. Okay, yeah, sure. Please do so. I'm really happy about it. And we're also going to add more docs on SnakePath in general on the VRF, basically some more details here and there. If you have suggestions for the docs, if you think that's not sufficient enough, please don't be gentle. Just ask us to improve it. We're really happy to do it because we want to have as many devs getting their hands on this as we can. I think we have quite of a nice piece here on software with Secret VRF and SnakePath in terms of gas efficiency, in terms of like ease of use. So it's important that we get this out. But yeah, token messaging, we thought about this. The problem is that SnakePath is itself trustless because it relies on this one master gateway contract. We can't do token messages, but you don't need to be disappointed. We have another solution as well. So we have multiple solutions. So for example, we have SnakePath for fast bridging, but we also have a bit of a slower messaging type, which is Axelar GMP. Maybe Sean has some docs on it. So he wrote a lot of docs on this, and you can use that for even bridging tokens. Yeah, exactly. You can use Axelar GMP for this. If you have questions on how to use it, please just ask us. There's a lot of interesting things you can do with Axelar. Exactly, yeah. And you can use Axelar for this, definitely. SnakePath still has a lot of awesome, yeah. Yeah, please. Let's just do this after the call, after I finish the demo, and then let's do it afterwards. But please just, DM us or whatever you like. Sure. Okay, let's go through the presentation again. Perfect, awesome. Okay, so now the idea is, after we got the EVM stuff done, how can we do this in a Cosmos ecosystem? I wanted to quickly go over it because it's mainly, I think it's a bit out of scope for this talk here, I think. Because the thing is, most devs that are already know IBC already know IBC hooks, so we're not really doing something groundbreaking new. What we did instead is we just made it super simple, and I think that's the beauty of it. So I can just show you the code, and if you'd like to know more, I also show you like a small demo of the code itself, just explaining what we're doing. But in essence, what we can do is, we have one main competitor in the space, which is, in our case, it's Noise Blockchain, which provide random numbers. The thing is, their approach is completely different to ours, which their main approach was they're gonna do separate contracts on each chain, which we think isn't the way to go. We think we need to get this. We can piggyback, in general, this VRF stuff into existing IBC infrastructure. There's no need to be like extra contracts. There doesn't need to be any extra IBC relayers or channels or whatever. What we can use are IBC hooks. So as you can see, we get messages basically from the Cosmos ecosystem. You request some random numbers and you take an IBC hook to get Secret VRF, to get some random numbers, and then the Secret VRF contract will give you an IBC hook back and send it back into your contract. IBC hooks are super versatile to use, and they don't need to have any extra setup, so you can use them with any normal transfer channel. So what an IBC hook is, an IBC transfer is usually what you have in the Cosmos space to send assets between Cosmos space chains. So for example, between Juno or Secret, could also be between Cosmos Hub or Secret, Osmosis or Secret, Archway or Secret, Neutron or Secret, whatever chains you have connected with IBC and support normal transfers, IBC transfers here, are compatible. There's no need to do any extra work, no extra channel, no extra contracts, nothing. That's it. You just need to drop in our code that we have. So in that case, what we do is an IBC transfer, for example, can contain a memo. So there's a small, maybe you can, if you do an analog in EVM, it might be something like a call data. In that case, we can have an IBC memo, and that hook contains a message. You just call a WASM, a contract, and you have your message, which requests a random number. And we can execute contracts in secret that way. That's it. And what we can do is for the callback, essentially is everything that we need. We send a small amount into secret. Stuff will be executed, and secret takes care of all of the rest for you. You don't need to do anything else. You just send in the message. Secret will handle the callback, a separate contract, which is the idea is a bit similar to SnakePath. Essentially, the contract in secret itself will generate the random numbers, and then it will sign these random numbers. So it will sign this randomness again, put its signature onto the result. And what you can do is then it uses an IBC hook, backwards to do the callback. So we'll do an IBC hook in a way back. And because this can be maybe forged, what we made sure is that this contract in secret, which only secret can do because it has confidential computing, it's the only chain that can really do this it's the only chain that can do this in the Cosmos ecosystem and in a bunch of other chains as well. Secret is really special in this. It can actually sign this again. We did with SnakePath. We can sign these messages. We can put our signature onto this. And this signature is everything you need, because that way you can be sure that this stuff came from our randomness contract on secret. There's no extra work to do. You just need to verify the signature. That code example is already enough. You just drop this code example in, and this will do a verification, a sec p256k1 verify, and it will verify if the signature is correct or not. If the signature is correct, you can be assured that the randomness is indeed actually the correct one. And that's all about that you need. You just need to call the IBC. We have an example contract for this. We have this here as well. You just drop this into your contract and you're done. That's it. And you need to import 2 libraries, but nothing that's makes it incompatible for your chain. What we made sure is we have it structured as such that it's actually compatible to as many Cosmos-based chains that you can think of. As long as you have IBC hooks on your chain enabled, which I think most devs will already know already, because if you're a heavy user, you will have it. As long as this supports IBC hooks and just normal IBC transfers in general, that's everything that you need. No extra channels, no extra fancy setup. You just have to drop in the code and you're done. That's something that we cranked out last week, so we wanted to specifically make this for this workshop as well. So if you are an IBC expert, please stay if you like. If you don't, feel free to also leave if you think so. But I think this is also interesting for anyone who actually has some sort of, let's say, connection with Secret and in general with the IBC Cosmos space. So if you're not from EVM, this is pretty interesting for you. So that's our prime example of how to distribute VRF into the Cosmos ecosystem. I'd say this is the easiest way to do it. Maybe it's not, I'd say from the code quality, it's maybe not the cleanest way, I'd say, because we had some discussions with other devs, but I can assure you it's probably the way that's most compatible, and that's actually the easiest one for you to implement. Let's just give you an example for this. I will just show you the code, because if you're going to do the transaction, it's going to be like a bit messy. But I can just show you the code, and as it is a bit more, I can just give you more explanations afterwards if you'd like. So I think this is more specialized in our case, but feel free to ask questions about it anyways. Of course, as always, there's no dumb questions, just ask. So I'm basically back here in the contract. So what we have is we have a sample contract that was made jointly with Sean Rad and me. Basically, we had a lot of work done. Sean did awesome work on this. I, of course, did also some work on this. So in essence, what you need to do is import some libraries here. We're going to have this in the docs as well. You have to import, sorry, that was the wrong contract. You have to import just some libraries, any buff by 64 and SHA-2, so nothing too fancy, I guess. These are standard Rust libraries, and that's everything that you need for the contract example. And what you then need is basically for requesting a random number, you just create an IBC hook. This is an example you can easily copy paste into your contract. We made it sure that it actually is compatible with as many chains as possible. We are constructing our own message. You're not dependent on any struct types or whatever. We just use any buff to construct our own IBC message with a memo, IBC transfer with a memo. And we will also create the IBC hook. So that way you don't have to do any work. I'd say you just need to copy paste this code, put it into your contract, and of course, don't forget, please add the message here to the response. So that way this is actually called. But that's everything that you really need to send a request. That's it. You don't need to do any extra. That is it. There's nothing else to do for you. Just copy in this code, import the messages. That's it. Should take you not more longer than 10 minutes. What you need to have, and this is important, we need to have these contract addresses and verification key. This is a public key. So what we're going to do, so we wanted to actually, do a sneak peek. This is kind of a sneak peek, so keep this in mind. What we have is we will give you an address here, which is the secret address on the secret side. That is the VRF contract, and we have this verification key. And using this verification key, you can always make sure that the message actually came from this contract in secret. And then you just need to define your IBC channels. Again, this is more for the IBC lovers here and who love the interchain. We're really happy to help you out with this. We have like lists and tables, of course, for all of the channels. So that way we can make sure that you don't accidentally put some wrong channels in. But most important thing, I guess, is for you is just to get the correct channels. We have tables for this. So please, if you have questions about this, please ask us. This is important. I'm really happy to help you about this because this IBC is also something that we wanted to get as many people we want people to get their hands on this for the IBC, for the interchain in Cosmos as well. Now the thing is, after you requested your random number, so that's basically the code that you need to drop in, you can just say what's your job ID. You can pick your job ID as you want. So you can take your custom job ID, name it as ever you like. It's a string, so you can just name it whatever. It's like my job ID number 1, 2, 3, whatever. Everything else will be handled by the contract, by the code here in the contract. So nothing else that you need to worry about. Then stuff will be executed in secret, and it will be sent back with an extra IBC hook that is called receive random. And as I said before, it will do the signature verification. And when that step is done, you can drop in this code here, and you're done. Boom, that's it. You don't need to have to do any extra legwork. You are done with the verification, and you can, do whatever you like to do. Stuff is done from that side, and you can make sure basically that it ensures that the random number is actually coming from the secret contract, and that's exactly what we wanted to know. So we have the randomness here and the job ID basically together, and that way we can ensure that no one actually manipulated a job ID or the random number along the way. So if someone actually manipulated these values along the way during transit, this would result in a different signature, and this would actually fail the verification. So if the job ID that you define can be anything that you like, or some random number basically is manipulated, it will throw an error and it will, error out. And that's it. You just need to do signature verification. That is it. You don't even need to trust the IBC relayers for this one. That's the beauty of it. So if you don't trust the IBC relayers, you don't have to. You don't need to trust them. You just need to trust the contract in secret that it actually signed this. And we have the contract, of course, available. It's completely written also in Rust, of course, also in secret. And we have the whole contract written in here for you. So you can also check it out on the repo. I think Sean has the repo available. Do we have the link here? I think you can just include this one while I'm still talking. But aside from this, that's it. So it's a pretty simple drop-in as we wanted it to be with SnakePuff. It's not as small. I have to admit this. It's a bit bigger, but in general, the idea behind it is this is super easy to implement into every single chain that you have. You don't need to have any special structures or like anything. You don't need to do any type conversion or anything. You just use this target message, which is supported on basically every chain as long as you have IBC. And you just create your own hook memo that we have the template for, and you just do the signature verification. These are the 3 main steps for it. And that's it. You got randomness on every single Cosmos chain supports IBC transfers and IBC hooks. That's it. There's nothing else to be done. There's no special things that you need. There's no special IBC channels, no special contract calls, nothing. It's that simple. And that's why we wanted to get this. That's why we actually wanted to have this in this presentation, even though it's not in the absolute fullest form with the docs right now. Sean is working day and night to make sure the docs are polished up for this for you. But we definitely wanted to show this to you anyways, because it's super nice. And for example, if you have even a bit more experience in, let's say, with IBC transfers and anything, just come to us. If you don't, also come to us, please. We want to give this in the hands of everyone who's familiar with IBC transfers and maybe has a dApp on Osmosis, on Juno, on Neutron, on Archer, on every single IBC chain that has WASM contracts and is try it out. We're happy to assist you. Exactly. So that's the workshop. Exactly. So, any more questions about it? If not, then I think this concludes the main part. So thanks for joining. And I actually have some more details for you. In that case, let's switch the window again. Let's go here. And let's show you the SnakePath repository. So we have SnakePath here. We have the VRF demo if you'd like to see it. I also put the link into the description, into the meetings chat, sorry. And I have some docs for SnakePath and how to use SnakePath. And also we're going to distribute docs on how to use IBC hooks with the contracts. So yeah. Any questions about this right now that you have in mind? Please just say so. We can easily get to them. Ah. If not, let's just wait 5 more minutes and then let's just finish the live stream for today and the presentation. But thanks everyone for joining today. It was quite pleasant, and I hope you've learned something today. I hope that I didn't confuse more than I enlightened. Anyways, if you have questions or got confused more by this, just ask me. We're really happy to help you out, Sean, Red, and me. Yeah. So thanks for joining today, and I hope we will see you on Thursday for the next presentation. We will have another one on Thursday, which is, let's see as it is. So we have the pitch perfect deck or perfect pitch deck. I think that's the right direction. Yep. Yeah. So happy to join you for this. As part, you guys also have a pitch deck for the hackathon. So make sure to also join this one. And yeah, thanks for joining.